So I was looking at these lamp kits and thinking, well, it's nice, I could make it with LEDs, but I quite like the housing with the globe, the dome in the end, the clear dome. I thought, could I make it with neon indicators? I mean, I could make one that is just lots and lots of neon indicators and resistors. Then I thought, what if I did it in my sort of nixie-flower style? So the circuit board was just one huge big nixie-flower inside the globe. That would be quite nice. So I've been in the printed circuit board design package and I've rattled out a circuit board. Now I use, just for reference, before people ask, I use Sprint Layout, and this is Sprint Layout version 5. I think they've moved on to version 6 since, I don't know if there's much difference, but I like it because it's a very simple package. It's very much like the first printed circuit board design package I used, which was Boardmaker 1. Instead of forcing you, like a lot of the, like Eagle and the other higher profile packages, well, I wouldn't say they're necessarily higher profile, but the more sophisticated packages, a better description. Instead of forcing you to actually do a schematic and then, you know, name every component, Sprint Layout just lets you bang down pads and tracks. You know, you don't even need to actually pick a resistor and put it on. You can say, I'll just put 2 pads to the resistor and then just put the wee box in. You can do anything. So this is the circuit board that I've designed on it. And I printed that off. Well, actually, it doesn't really matter which way up it is because all the text is random directions here. These are just little notes. Because this is a prototype circuit board, it's not got a screen print as such, and there's not much room on it for adding screen print. I have just initially, I've just put component values just as memory joggers because I'm only really interested in the tracks. And I've printed that out onto a suitable film. This is the screen printing industry film. It's the sort of special inkjet transparency material for screen printing, which is it's translucent. It's not clear. It's not like the normal clear acetate, inkjet acetate. This actually feels very sticky and sort of creaky, and it just takes shitloads of ink. It's designed purely for ultraviolet exposure. So what I'm going to do now, I'm going to do it in the trash style. I could crack out my huge expensive tubes and lid ultraviolet unit, or I could use this nail varnish curing device. So I'm going to use the nail varnish curing just because I do want to. It's a small circuit board and I do want to try this out. So I've got my laminate here, and I'm going to have to experiment with times. I can't remember if it exposed properly in 1 minute or not last time, so I'm just going to peel off an edge of this. This is photosensitive board. And it's got a black protective film. You have to be careful not to touch the surface underneath and get greasy fingerprints on it, because we're going to be developing it later. So now I'm going to put the transparency film down on that, with the printed side facing down in this instance, and I'm going to place it down here, put that nice and sort of central-ish. I'm going to put a piece of glass on top to weigh it down. There we go. And then I'm going to sit the ultraviolet unit over it. This is the nail varnish curer with the ultraviolet tubes, which seems to work quite well for small circuit boards. And then I'm just going to press the button and I'm going to give it an exposure. Now I'm trying to remember, I did a video on this before. I can't remember how long I exposed, if it was just 1 pass or 2, so I could mess up this circuit board. But I'm going to expose it now, and then I'll develop it afterwards, and I'll be back shortly. Well, I've now exposed and developed the circuit board using my preferred developing solution, which is sodium metasilicate in a ratio of 12 grams of sodium metasilicate in 250 millilitres of water. And now this is kind of like my Sino GS etch system, but this is one I had to improvise myself because I really messed up the other one. I tried to give it a little zap in the microwave and all to warm it up, and unfortunately it damaged the plastic. So this is a dodgy experimental version that I've just got some of the heat seal tubing, and I'm going to give it a go. So let's see if I can make a mess here. I'm trying to remember the way I normally do this. These are also, just for the sake of completeness, these are also bag sealers, just generic ones off eBay, just as an experiment to see how well they work. So I had lots of opportunity to make a terrible mess with ferric chloride here. The Sino GS system is very good, but don't microwave it, obviously, like I did. So here we go. This is ferric chloride in here, and this is going to take a while, but the first thing I want to do is check. I want to get the circuit board up to one end. I'm getting a lot of copper settling out of this in here by the look of it. I want to check that it is all developing. I think it is all etching okay. Right, okay, so I'm just going to just gently undulate this backwards and forwards without putting it under too much pressure in case it explodes open and gets ferric chloride everywhere. So I'll be back shortly. Okay, that's been thoroughly agitated. It also turned out that the residue that had formed in here was actually just undissolved ferric chloride, so I managed to dilute it with a bit more hot water, which helped, because hot water always speeds up. So now I'm just making sure as much ferric chloride goes down into the bottom section as possible. This is how the Sino GS system works. I'm using something based here on the Sino GS system, but this isn't the actual Sino GS system now, just because I burst my Sino GS system in the microwave. So now I'm going to seal off the ferric chloride in the bottom here by folding the bag over and using one of these bag sealers and just slipping it on. If you're just doing a small amount of ferric chloride etching at home, I would recommend the Sino GS system if you can get it. It's very clean. Because what I'm going to do now is, now I've sealed the ferric chloride away, I'm going to take this through to the sink and I'm going to wash the circuit board just by removing this top bit, and it keeps the ferric chloride well away, and it just means I don't even have to handle the circuit board until it's been fully washed. So I'll be back shortly. So that's the residual etching cleaned off, and I'm ready to drill it now, and for that I'm going to be using my trusty old Minicraft drill. I don't even know, are these still made anymore? I think I got this from a place in Glasgow called RME, Radio Mechanical Electrical on Howard Street, and that shop's long gone, but the main thing that you want in these little drills, it's a low volt 12 volt drill. The main thing you want is a bearing at the tip, because you want that shaft to be absolutely rock solid. You don't want any slop in play. So I noticed that on eBay you can get little printed circuit board drills that are basically motors with a little collet in the end. Maybe they work, I'm not 100% sure. I've not tried one, maybe I should try one. But in the meantime I'll be using what I traditionally use. I have drilled tens of thousands of holes. I can't even imagine how many holes I've drilled with this. Now I'm going to be using a tungsten carbide bit. Tungsten carbide bits are super hard, but they're also very brittle. They're used by the CNC printed circuit board making machines that drill the holes. And you get packs of 10 that have been used on those machines, and it makes it a lot cheaper, because if you buy them new they're very expensive. So I get mine from Rapid Electronics in the UK. However, now this is, I'm using 0.8mm because the leads of the components that I'm using are all pretty thin. It's worth mentioning you have to hold this with an iron hand, because if you slop at all you will break these bits. The main advantage of the tungsten carbide is that it won't blunt very quickly. It just eats its way through fiberglass based laminates very quickly. Now what I've done here is I've made a slight boo-boo here, in the sense that I was being overcautious with the developer. So I didn't fully develop it, I just got it as soon as the track layout was there. I just pulled it out of the developer and rinsed it off. And when I'm designing the circuit boards, the pads, I like to put a 0.5mm hole just in the middle of each pad, just you know, just for the prototyping. If I was designing the circuit board file for going to the manufacturer, it would be the correct size of hole in all positions. But in the case of the prototyping, I like to put a 0.5mm hole just to help align the drill bit, because when the drill bit touches the middle of the pad, it will align on that tiny little indent that's left through the etching. But that's not happened here, so I'm going to be just basically having to aim it manually, which may not end very well. And my apologies if you get headphones on, because well, the drill's not very noisy, but it makes a modest amount of noise. But here we go. So I like to put the cable over my shoulder when I'm doing this, just because it's got the coily lead and it keeps it out the way. And also another good thing to do is, before you start, calibrate yourself by just drilling random holes. Just drill several holes in the laminate surrounding the area you're going to be drilling in, just to get yourself sort of accustomed to the feel of the drill. And here we go. This would have been so much easier, those wee indents. Oh well, I'll have to be more careful next time. I've not perfected my ideal, I've not been making too many circuit boards recently, so I've not really perfected my ideal choice of exposure time, the transparency and so on. I don't think the Epson printers are 100% suited to making transparencies. In fact, Epson printers don't seem suited to anything at all. Particularly now that I'm on Windows 8 and the Epson have hobbled the driver. They've not made a driver available for the printer I'm using. And so Windows uses a default printer driver which just basically doesn't even let you use every type of paper size. It's all very annoying. I do not like Epson. They're the ones that don't really like you refilling your own ink cartridges and so on. They're just very profit motivated, a bit of a control freak company. So I might be getting a new printer soon, I think, maybe a Canon. I've always liked the Canon printers because the Canon were always easy to refill and were just rugged, sensible machines. I was kind of like really disappointed in my last Canon. The head burnt out on it, and that's a shame because it was just a great printer. It was very accurate in feeding paper through, so you could put you could put a transparency through several times and it would do this super accurate print alignment on them. It was very good. Oh, that's the most squint hole yet. Right, okay, let's see how that is. Usually you can tell from the other side if you missed one because you see the patterns missing, but I think I've got all the holes there. Yep, that's looking pretty good. So now I'm going to crop this circuit board down. And the first thing I'm going to do is take this drill bit out, because if you don't and you drop the drill, because it's got the coil lead in it, it will break the drill bit. It really is so easy to break these. I remember when I first started using these, I'd just go through batches that I'd just break, and I was thinking, oh god, the cost. But you know, once you get used to using them, these are great. Oh, they've also got a voracious appetite for human flesh. I've managed to drop the drill on my leg and it snatched into the thigh. Oh, that was sore. But the best ever was when I was drilling and I was just like, with the circuit board like this, and I touched the end of the finger and the drill went snatched into it, and it was like, oh, it was the worst thing ever. So, right, let's clear all this fibreglass and SRBP off. There's only one hole I'm not happy with that I just didn't quite get it. And these holes are nowhere near as well lined as if I'd done the wee indent, but they're absolutely fine for the application. So I'm going to get the guillotine now. If you make lots of circuit boards, a guillotine is the way to go. A printed circuit board laminate guillotine is just the way. And I'm going to crop it in a series of cuts that are going, because they're round circuit board, I'm going to have to finish it off with a file round the outside. Maybe even just Dremel the outside in to get it to the exact size. But initially I'm going to start sort of cutting it into a sort of what you might call polygon. A multiple-sided object, which will just mean there's less material to clear off. And before I put the components on, I shall finish cutting this round. So I'm just going to actually crop as much as possible in this guillotine, because it's so much easier than using hacksaws or Dremels or anything. It just really produces an absolutely super crisp line in printed circuit board laminate. It's a great way for trimming it. It produces a very clean line. The sad thing is that these things are really quite expensive. When I was young, I went through a batch that I was making a lot of custom circuit boards, and it just paid its way, really. You know, it just, you know, it's a fantastic tool. if you've got a high yield, because it saves a lot of time. So now I'm going to clean that up, and then we'll solder all the components in, and then it'll go bang. No, hopefully it'll work, but we'll see what happens. I'm also going to colour it black. I might just use, for speed here, I might just use a Sharpie, or I might paint it. I'm not 100% sure. Paint always takes so long to cure properly. So I may just use a Sharpie to blacken this up. So I'll be back again in a moment. Right, I think I'm ready to start building this now. In the end, I did paint it. Not quite the matte finish I wanted, but it's a black finish, which is going to make it more visible. Actually, in hindsight, maybe I should have just left it self-coloured, but that's, you know, just one of these decisions I made. Things worth noting, when you clean the solder resist off, you don't, not the solder resist, the etch resist off, you can use acetone. Acetone cleans it off really well, or you can leave it on and just use it. As you solder it, it just kind of clears off, and it does kind of protect the copper underneath. This is from the Wonderland we call Poundland, and it's classic pump it up nail polish remover. What's great about this is it's a little bottle full of acetone, which is a great general purpose solvent. And when you put a pad in this and press down, it pumps a little bit up directly onto the pad, and it's ideal for keeping the acetone from spilling everywhere, and it also keeps it from evaporating. Another thing that's useful for cleaning the copper is the traditional sponge scourer pad that you find in the kitchen. The green side is great for cleaning copper. It really buffs it to a, you know, it takes all the oxidation off the surface and gives it a slight matte texture as well. Really useful pad. So we're ready to put the components in. I've prepared some of the components by just bending the leads. I've still to do these components, and for this I shall be using, you could either bend them manually, but I'm going to be using this tool, which I think I've shown you before, which is a tool you put a component in, pull the trigger, and it not only crops the leads off, but it folds the leads. And it saves a lot of time. It produces very neat results, but it is an incredibly expensive tool. It's kind of designed for low-level manufacturing. Which is what I was doing when I bought it, which helped justify the cost of buying it. The other option was a full-on turn handle machine that you fed bandoliered components into, and it formed the leads, and it was just beyond the realm of, you know, the common sense. The cost was astronomical. It would only be suitable for an actual factory. So that's them cropped. I shall get those leads out of the way. I shall not put them in my floor, because otherwise I will stand on them, and they go through socks quite nicely. Right, anything else worth mentioning before I start putting components in? I had to salvage the 10 nanofarad capacitor out of another device, which is a bit annoying, but not to worry. It's just because I didn't have any. So I'm going to put some of these components in, and rather unusually I'm going to be putting some on from this side, because I don't want them on the component side. So I'm going to sit them on here, and I'm going to get some solder. That would have also been quite clever. Here's the solder. So I'm going to sit these components. I do this quite often, putting through-hole components on the copper side, just because it kind of keeps them out the way of the components on the other side, which is, in this case, it's being used for sort of cosmetic purposes. And it's quite easy soldering them on this side. So I've got, instead of using one 470k resistor, I'm actually going to use two 220k resistors in series, just because I thought, you know, let's spread the voltage a bit of it. They're certainly not being stressed either electrically or thermally. I'm thinking if the capacitor discharges to about 50 volts, so it would be pushing the voltage rating of the resistors on our mains 240 volt supply, which is 250 volts DC for these resistors. But it still wouldn't be that bad, because there'd be the significant voltage drop across the neons. So I'm just going to flow those on, and then I'll be cropping the leads at the other side, flush with the front of the circuit board, trying not to scratch the lovely painted finish in the process. The problem with using the paint, I've just suddenly realised I put my snips on top of my cable here. The problem with using the paint finish is that, you know, you should really leave it overnight to cure properly, and if you don't, it can actually just result in it scratching very easily. But I quite like painting my circuit boards just to match the application, either white or black or whatever colour suits. I wouldn't do it with all of them. If it's just a practical circuit board, I wouldn't do it. But in the case of something decorative like this, it adds to the finish. The sparkly metallic finishes are quite good for art circuit boards. Oh, there's an idea. I should do more art projects, LED art type things. So let's grab some snips. Let's grab the Xeron clone. Try not to scratch the surface paint. He said using relatively new snips with very sharp ends, which are probably going to scratch the surface paint. Okay, it's time to start putting the neons in, and this is where I may actually, I'm not going to put the capacitor at the moment because it's a wee bit bulky and it may get in the way of things. It's going to stop me sort of laying it down and it's just going to obstruct me getting to the solder joint, so that's one of the last things I'll be putting in. But I may actually use a jig for this. So this is a printed circuit board soldering rig that I got a long time ago, and it was just really helpful in manufacturing lots and lots of printed circuit boards, particularly square ones. It's not optimised for round ones, but it should work in this application if I just gently catch the edges of these. It might not work. So I'm going to put the first set of components in, and I'm going to have to nudge these afterwards probably. And it's going to be the first ring of neons. There's 8 of these neons on the outside. I just basically crammed in as many neons as I could, because it always looks better the more there are. It just looks more active. Another slight downside to the black circuit board is it's making it quite hard to see the holes, because the holes are black on a black background. So this set of neons will basically form a sort of bottom layer of what's going to look a bit like an I was going to say LED flower, but it's a neon flower. And then it's going to be 3 more layers of neons actually riding up on top of these ones. I'm not 100% sure how this is going to work, so I'm just going to have to play it by ear. I may not even be able to put it in the jig for the other ones. So that's the first circle of the neons in. I can fine tune their positions later on because the leads are quite malleable. So, and there's a wee bit of extra length in them. Now I get the other part of this, which is a foam pad that presses down the components, and I hook it over there, and this is either where it presses down firmly in the neons and holds them in place, or it just pushes the circuit board right through the back. So that's it clamped down. That's looking pretty good. Let's get the soldering iron and solder these joints. Because I don't like thermally stressing the neon leads, I will be soldering one lead at a time and then go back round them. There is a tendency in the neon indicators to have the leads of the neons crimped instead of soldered, and that's mainly because if the heat is held on the lead too long, it can actually cause microfractures of the glass envelope of the neon, and that can result in the gas, well, not so much the gas escaping as air getting in. Okay, so that's the first connection soldered. It gets a wee bit, because it's round, it gets a wee bit too close to the edge here, so it does make it that little bit harder for soldering. I'm not even sure with the next layer of neons if they're going to start riding up a bit, and because it is designed to be a bit sort of three-dimensional, and I'm not sure I'll be able to actually put it into this jig afterwards, but at least I got the first set of neons soldered in. So, turn this round, unhook it. I'm just going to pop the circuit board out at the moment and crop the leads. things that are worth noting, if you look at a neon, you'll see that where the leads go through, they're a sort of red colour where they go through the glass. The reason for that is the metal that they use, and the pinch seal is called Dumet, D-U-M-E-T I think it's spelt, and I think it's a blend of iron and copper. And it's chosen to match the thermal coefficient of expansion of the glass, and the idea is that as the glass is heated up, the metal expands at the same rate, and when it cools down, instead of if they cooled at different rates, then it could cause stress and it could fracture the seals. So by matching them, that doesn't happen. I'm going to set these little neons back a little bit now. I'm just going to pull them back to clear, because the pads for the next neons are actually right at the very tips of these ones. It is quite hard to see this because it's black. Maybe I shouldn't have made it black. Now, this is going to be very tight, because it is, as I say, designed to ride up a bit. I'm going to have to solder, I think, 4 of them in, and then bend them up and solder the next 4, because I don't think I'm going to be able to actually fit them in otherwise, because they're going to interfere with each other, so they're going to be riding up on top of each other. But that's just how the circuit board's designed. It is just really me stuffing as many neons in as I possibly could. If it's worth doing, it's worth doing with excess. Name the Disney ride that's featured on, which is no longer actually, I don't think. A fictional big corporation called Excess, who did things with excess and with violent results. I can't even remember which park that was at. I think it was the original Magic Kingdom, and it seemed strangely inappropriate for the actual ride. I'm not going to put this in the frame here. It seemed an inappropriate ride for such a sort of a park like that. I'm just going to press this down here to hold those in, then slide it out. Okay. That ride I'm talking about was a fear ride. And it wasn't really a ride, more sort of fear attraction. It just seemed strange that in a sort of like kiddie park it had something that basically involved monsters gnawing at your head. Right. Oh, that's my stomach growling. I think I'm hungry. I'm trying to remember if I had tea tonight. I think I had something to eat, but not an awful lot. Probably inappropriate food. Bachelor food. That just screams super noodles. It's a while since we had pot noodle. That'd be quite nice. The emergency food. Right. I'm going to have to ride these up to make way for the other ones to fit in, but that is by design, because these are forming the petals, the first section of petals of the flower. So in go the next set. Oh, this is very tight. In fact, I think these are going to have to, they're not going to split so apart, so I'm going to have to actually set them up now at the correct angle that they're going to be at. Very footery, but all the artistic ones are, they're just, you know, optimised for excess, really. Long time since I've been to Disney, Paris as well, apart from when I was working there. I have to say, when I went to what used to be called Euro Disney, I'm going to come back to that one because it's just not having any luck getting in. When I worked over there, the park, the Disney Paris park, is fantastic. It's really good, the original park, because it's almost like it was the Mark II version of all the best rides from the main Florida parks. It was very good. I went there not really knowing what to expect, and I've not been biased because I got in for free. Just because that's what happens when you're kind of working with Disney, really. I was working in the park next door, which is the studio park. But when we had time off, we went into the sort of main park. It was good. I quite enjoyed it. Right, I am one short for a bent one lead, so I'll just bend this one. And as I say, things like the Haunted Mansion ride at the Disney Paris were just like the Mark II version. It was great. It wasn't like the original version that was perhaps looking a little bit tired. They'd refreshed it a bit, but it was all the good effects from it, but just beefed up. Great, great park. Very good. Very impressed. I'm not just saying that because I was working there. I actually mean I really enjoyed the park. Another thing worth noticing there, oh, what was the name of the ride? It was the Dark Coaster ride, but it had a different theme. I'm trying to remember what the one in the American park's called. Oh no, it's not Thunder Mountain, but their version in Paris was more like the Rock and Roller Coaster in MGM Studios in Orlando. So then in the studio next door, because they were having a Rock and Roller Coaster, it had to be different again. And it's really fantastic. I got so sick in that ride because I just kept going round and round in it. Because again, you work in the park, you can do things like that while they're testing the rides. And it was quite good because in that ride, unlike the sort of strange sort of road trip ride in the MGM studio version, in America, the Rock and Roller Coaster in Paris, you're actually flying through the lighting rig, and you're actually flying through real lighting truss. It was very good. Really fast linear motor launch in that one. This neon is actually just soldered way too high, so I'm going to have to tweak that, and that's going to be a wee bit tricky because I'm going to have to try and heat both those solder joints at once. That's better. Okay, this is getting quite complicated. Right, I shall crop these leads, and that just leaves 5 more neons in the capacitor to go in, and then it's ready. And as you can see, it's forming this sort of glass three-dimensional sculpture now. So these ones go in there. Now this is going to be tricky. Not sure the best height to put these at, or how I'm actually going to mount them at that height without them slipping down while I'm soldering them. It's hard enough actually finding where I'm actually to put them into, because it really is tight for space in here. Sadly, when I was on the Rock and Roller Coaster in Paris, I didn't know the French for "please let me off the ride," because by the time you'd been round X number of times in a continuous cycle, it was like, oh, you know, initially I quite like roller coasters, but I've not got a great stomach for them, so to speak. And after a while, you just want off, because it's not normal to go around that particular ride X number of times. They also the guys there warned us before the ride started. They said it may do what they called, I can't remember, it was code something. And because it was a linear motor launch ride straight into a loop, there's a situation that can occur that it doesn't make the correct speed. And if it doesn't make the correct speed, it has to do an emergency stop, which is never a good thing on a linear launch system. So they warned us that if it did that, it would come to a very violent stop. And fortunately it didn't, because that would have been quite unpleasant. I'm looking for something I can sit this on that's going to prop these neons up. That's not quite right either. I just need the perfect thing. I may have to just solder these manually and adjust the height manually. I think that may be the case. This is where the jig just definitely wouldn't have worked, because it's too much. It's too three-dimensional. So I'm actually going to solder these, but I might actually just tweak the height afterwards to match them. These are like, not quite, these are kind of the stamens in the middle of the flower. but there's also one more neon to go right in the middle and ditto with the one that stands the highest. They're not bad. They're all pretty much the correct height. Yeah, that looks alright actually. Yep, I'm quite happy with that. I might nudge this one a tiny bit. No, I won't, because if I do, I'll just end up messing it up. That's what happens when you keep tweaking things. Disney Studios Paris had a lot of new, interesting rides. Just stuff that, you know, some of it was based on existing rides, but a lot of it, like Armageddon and the Cinemagique attractions, were not. They were completely, radically different. They were almost like a test ride, and if they were a success they might get taken into other parks as well. I'm not sure how that worked. Cinemagique was a very large scale, it was like a huge cinema, but with it was interactive. It had loads of special effects and loads of dodgy trapdoors on the stage. I fell down one of them, which is quite easy to do actually when you're working on them. And the attraction basically involves a sort of history of film, but with an actor who goes out the audience, he's a sort of plant in the audience, and gets sucked into the action and then just jumps in and out the film. That was quite a good system. It worked very well. It's one of those things you're thinking, is that really Disney? Is that going to work? And then, yeah, it did. Totally worked. It was very good. The special effects were very good. There was one of the Imagineers from the mechanical engineering side of things. The stuff he was putting in there was just really ferociously immense special effects. Huge big daggers that would explode out the stage, and the stage would open, a sort of flap would open for the thing to come up, and then it was actually quite dangerous. If you were on the stage and it came up under you, it would probably fire you into there. But then again, nobody is in the stage, it's all controlled, and the actor knows where to be and when, and there's safety function built in. So that looks like a bit like what used to be called a matchless star. That's very stylish, isn't it? So now I'm going to add the final component, which is the capacitor. And then I'm going to solder the leads on, and then we'll give this a test. But it will take a wee while to quite get up to its full flickering potential, because the LEDs, the neons should I say, have to sort of age up a wee bit. They have to get sort of in the swing of things, and you know, there's a slight tolerance that will gradually match. So I'm not sure how long it will take for this to get ready. So I'm just going to fold this down, this capacitor, just to keep it out of the way. And then I've got two mains connections going on here and here. Rightio. So that's the back of the circuit board. That's the front of the circuit board. Let's see if it fits into the lamp holder. So here's the lamp holder, and I'll just tin these leads and then solder it on. And hopefully this will fit in. And the dome will hold it in place. I'm looking at that and thinking it looks really stylish, just, you know, as it is. Like a sort of glass brooch almost. The Armageddon ride was also interesting in the sense it was one of the rides that not sure if you'd call it a ride, it's basically a showcase of special effects. And you're basically going into a space station that then just blows up around you. It has a bit of an incident with meteorites. It was very good. Another attraction there that was also very good was the special effects, the Stunt Cars, which then did get adopted and taken to other parts of the Disney Corporation. I remember them having problems with their health and safety getting involved and saying, you know, they didn't like the fact that a car jumps into the audience. It didn't quite jump into the audience, but it came very close to the audience. It jumps over the river in front of the audience and then goes into sort of like a port. If you go online and look for the sort of car special effects thing at Paris, you'll find it. Right, that's the circuit board sitting in. Will the dome clip in? The other one was really tight, so this one, there we go. Right, so there is our neon oddity. So I'm going to test this and let it warm up, and then we'll take a look at it and see how it looks. So that's it after a few minutes, and it's looking pretty good. It's looking very active. It's not fully bedded in yet, and we do have the inevitable dominant lamp over here. But that's okay, it'll settle in after a while. And it's looking very three-dimensional. It's also quite noisy, I have to say. I'm going to have to consider an alternative capacitor, maybe a metal film capacitor, instead of the ceramic one. The ceramic ones are always that little bit noisy because of the piezoelectric effect of the distortion of the actual ceramic layer when the capacitor discharges into the neons. But yep, it's looking pretty good so far, and given time, it'll eventually, every single neon that will be continual active. So yep, it's looking pretty good. And the power consumption isn't even worth even trying to calculate. It's as good as zero in this application. It's just really a decorative light. So yes, it's a nice effect. It's turned out very well. This isn't super bright, but it's an amazing effect. It's a diffused dome over the nixie-flower inside, and it just gives it this incredible sort of three-dimensional sort of fire inside a globe effect. It's very, very weird. Very pleasing. I like this a lot. I'm not sure, I like the clear flower inside the clear dome, but this is definitely a different dimension. It's quite interesting. But you could go a lot simpler. You wouldn't have to use, well, you certainly wouldn't need the flower shape. It could just be a mass of the little neons, even in a grid. It's quite a good effect.